Okay, so we're going to be working on writing the equation for exponential growth and exponential decay, and these are going to be half-life problems. So let's start off with the basic equation that we're going to be using for all half-life problems. Okay, so I'm going to just jot it down here. So what the formula looks like, and this will be given to you on the test, so it is not something that you have to memorize. Okay, so we're going to write it like this. Now, what each of these stand for, this is your initial amount. In other words, that's what you're starting off with. This is your growth factor. In this case, it is a decay. Okay, and this here is your time for a half-life. So in other words, if they tell you a half-life is 6 hours, then that's what would go there. This is the time that we're talking about. So the given time that you're talking about, so whether it's over 100 years or whatever, okay? Your A value here is your final amount after T, okay? So in other words, if your time here was 75 years, this would be how much you would have in your account after 75 years, okay? So that is the formula that you want to have jotted down. Okay, now you could also put this as 0.5 if you would like, versus 1/2. Okay, so let's just look at the first problem that we're going to have. And so it says a hospital prepares 100 milligram sample or supply of technetium 99, which has a half-life of 6 hours on there. So when we look at it, and you're not always going to be given these A, B, C, D. Typically it'll just be, there's the problem and they want the final answer. But this one is going to take it through steps. So the first thing that it asks is, what is the decay factor? Well, we are talking about a half-life, so our decay factor would be 1/2, or again 0.5. What is the length of time for the half-life? So every half-life is going to occur every 6 hours. Now, again, just looking at what that means, if you think of it like a T-table here, this is your time of a half-life, okay, and this is your amount. So if I start with 100 grams, that's my initial, that would be your 0. In 6 hours, I would have 50. In 12 hours, I would have 25. And so forth. So that's what we're meaning by the half-life. Every 6 hours, we're going to have half as much as we started with. Okay, and then the next one is to write the equation. So again, I'm going to go to the equation that I gave you, and we're going to fill in the numbers. Okay, so I am looking for A. I am starting with 100 as my initial. Again, it is a half-life problem. And I'm looking for time for every 6 hours that a half-life occurs. So that is my formula. The next thing it says, it wants to know find the amount that's going to remain after 75 hours. Okay, so in this case, I'm finding how much we have, okay, at the end of 75 hours. So 75 is my time every 6 hours. Now, when you go to do this problem, one of the things that I would either suggest that you do, one of two things. Be sure that when you put this into your calculator, you need 100 times 1/2. You could do the caret key if you want, 75 divided by 6. Okay, if you want to put it all in at once. Now, some kids like to take and put in the 75 over 6 and get a decimal value. The only problem with that is if your decimal value is not terminating, it's some kind of repeating or irrational where it never repeats, then you're going to have trouble with that. So my suggestion would be to put it in this form, okay? And do be sure you get the parentheses in there because you don't want it to take it to the 75th power and then divide that number by 6. You want it to divide the 75 by 6 first, okay? And then you can run that number in your calculator. And I got in my calculator, and usually we'll round it to a couple of decimal places. Okay? And so I have that we would have 0.017 milligrams left. And you could check that. Now, another way to do check it, okay, and that wouldn't help you with the equation, but you could just continue this until you're to somewhere close to 75. Now, it's not going to get exactly to 75 because that doesn't come out even, but you could at least get it to 72 and see if you're close to this number. And then if you went with 78, you should be under this amount. Okay? So don't make these overly difficult. They're really not that bad. So I'll run through another one for you real quick. Again, we are doing a half-life again. It's for 17.5 days is how long it takes for it to occur. And we're doing arsenic 74. So again, your decay factor is a half because it is a half-life. The length of the half-life is 7.5 days. Okay? And our equation again is this is how much is going to be left. We're going to start off with a 90 milligram sample, which they didn't tell us up there, so we do kind of have to look down below. Okay? 1/2. And you could just put A sub there, A sub 0 there, I guess, in that part if you wanted to, but they should have flip-flopped this. And then again, we have after 6 days, but a half-life is 17.5 days. So we should know that our answer should be above 45 because it takes 17 days for it to half-life to 45, but I only had 6 days in which we have had a lapse. So again, we're going to put that in our calculator. I didn't run this one yet, but 90 times, again, if you want 0.5, that works great. And I need it to the 6 divided by okay, and I get a final answer as 70.96. You guys double check that value because I'm using a random calculator and it didn't have the caret key on it. Okay, so if you don't have the caret key, you could use the Y to the X key on that. But that sounds reasonable, again, on there. Okay. Let's see if there's any of these that are different. Nope, these all look to be exactly the same. So go ahead and try a couple of those and see how they go.